Hello and welcome to this Edexcel Further Maths Statistics 1 video, Size and Power of a Test. Here you're just reminded of the definition of a type 1 error, and the size of a test is the same as the significance level of a test alpha, or the probability of a type 1 error. When we looked at type 2 errors, we looked at the fact that it may be that whatever it is that's happened to the population has changed circumstances from the null hypothesis, but that might not be picked up during the hypothesis test. And remember, it's quite useful to look up and do a bit of research on what effect size of a test is. And quite a simple one perhaps to research is one called Cohen's d. You'll recall the probability of a type 2 error is denoted beta, and 1 minus the probability of a type 2 error is called the power of a test. It's the power to reject a false null hypothesis. So a high statistical power for a test is desirable because it should pick up when there really is an effect to be found. Conventionally, an adequate level for power is set at about 0.8, but this does vary depending on circumstances. So if we have a look at this example here, and I would suggest you pause the video for a moment and just read through all the information and think about part A, how you would find the size of this test. So the size of the test, or the significance level, is the probability we reject H0 when H0 is true. So it would be the probability of falling in the critical region when lambda is indeed equal to 5. So you may have a calculator you can use to evaluate the probability of getting 0 and 1 or 10 and more when lambda is 5, and that's the method I've used here. Or you may use statistical tables when you would work out the opposite of what we want. So you could do 1 minus the probability that x lies between 2 and 9 when lambda equals 5. And that's an equally valid method for evaluating the size for this test. So part B wants us to find the power of this test, which is linked to the probability of making a type 2 error. And remember, if we're trying to evaluate a type 2 error, or a power in fact, we do need more information about what the change is from the null hypothesis. And here we're told that actually lambda isn't 5, lambda actually is 6. And if we simply work out power using the definition of 1 minus the probability of a type 2 error, we require the probability that we accept the null hypothesis, and we know our critical regions are 0, 1 and 10 and above. So in order to accept H0, we need a value of x between 2 and 9 inclusive, but we need to evaluate that probability in the case when we're told that lambda has changed and lambda actually equals 6. And having evaluated that probability, the power is 1 minus the probability of making a type 2 error, or 0.101. Again, I'd suggest you pause the video at this point and read through this second example, and do think about the distributional model we are going to use in order to work out probabilities for this particular scenario. And hopefully you can see that we are looking at an event, a component is faulty or not, out of a sample of 50. So we can model the situation with the binomial distribution. And it would be a good idea to define the random variable x as the number of faulty components in a sample of 50, and then we can write down the distribution of x as binomial with n is 50 and p whichever value we're going to use for it. So having worked out the model we're going to use, we need the size of the test. So the size is the probability of type 1 error. So we want to reject the null hypothesis. So x needs to be greater than 4 when p equals 0.05. And you should be able to evaluate that probability from a calculator, possibly 1 minus the probability x is less than or equal to 4, when p is 0.05, and obtain the size for this test. So part B wants us to look at the power of the test. And again, note we have been given a different value for p. We now know that p actually is 0.075. And just using the straightforward definition that power is 1 minus the probability of a type 2 error, the probability of a type 2 error is the probability that we accept the null hypothesis, which means x must be less than or equal to 4, when p actually does not equal 0.05, our null hypothesis is not true, p equals 0.075. And that's very simple to evaluate, and then find the power, 1 minus the probability of the type 2 error, and we have our power for this test. And that concludes this video. The next video will look at examples of use of errors, size and power.